Hi, I'm Ben Fike. I'm an architect and programmer, and in this video, I'll be sharing a plugin for Rhino I've been working on that generates building layouts. When I was in architecture school, at the beginning of projects, our first assignment was always to create bad building layouts, or layouts that technically work but may lack those moments that make architecture special. It was a tedious task, but it helped us understand the scale and relationships of rooms and how these rooms relate to the site and the context. So I've been working on a plugin that allows architects to more quickly and easily understand these room and site relationships by generating building layouts based on user inputted site and room data. So I have a file open which shows a property surrounded by a few site conditions. We have a forest, a pond, a street, and some power lines. So what we want to do is generate building layouts that respond to these conditions. So we can navigate to the building generator plugin. This UI lets me input information about the site, such as the property lines and their required setbacks. We can enter areas we'd like to avoid, such as the power lines, areas we'd like to build on, or surroundings, such as the street, the forest, and the pond. So for now, we can open a file I've already made, which has this site information filled in. So you can see we have the curve data from the Rhino file and the amount of setback from each of these property lines. And we have site conditions such as these power lines, we have the forest, street, and pond geometry all inputted into this system. And next we need to make the building that we'd want to be generating. So for this demonstration, we'll be creating house layouts because it's easy to understand how the rooms should relate to each other, but the room names and building type could really be anything. So I can enter the room and square footage here. So for example, we might want an entryway, and that could be 75 square feet. And we want to tell the computer that we can walk through this building, this room. And then we'd also want a living room, maybe 150 square feet. And we also want to be able to walk through this room on the way to other rooms. And so once all those rooms are filled out, we can go to this experiences tab and see how we want these room relationships to really work. So the entryway should be near the street. The entryway should also be maybe adjacent to the living room. And for this site in particular, we want the living room to have a view to the pond. So I'll open up a file I've made that has more rooms on this house. So I'll open up the house file. We have the same site conditions. And a larger house, we have the rooms we inputted plus a few more. And we also note which rooms we're able to pass through. So you can walk through the entryway to get to the living room, but you wouldn't be able to walk through the office to get to the living room, for example. And then we have the experiences, the relationships we'd like to create between the rooms. For example, the dining room should be close to the kitchen. Master bedroom should be adjacent to the master bathroom. And so now we can start to generate building layouts. So this solver algorithm builds each layout by joining rooms one by one on the site and scoring the resulting layout by what percentage of the rules have been met. Then each room order is partially shuffled and another layout attempt is made. If the new layout gets a higher score, this process repeats using the new layout. If the layout's worse, this process repeats with the previous best layout. So there's a probability that a worse scoring layout will be accepted, which actually prevents the algorithm from getting stuck early on in the solving process. Each of these rounds is a layout test. After many rounds, a local maximum score is reached, so it helps to reset and try again with slightly different conditions. So we'll start with 20 rounds per set and 5 sets. And we can hit generate. Now you can see the layouts being generated. Each black square is an attempted room placement, so the solver finds the best location of each room and then scores the entire layout. The highest scoring layouts are outputted as separate layers shown on the right. The most recent high scoring layout stays visible on the screen. And this building has 11 rooms, so on my computer each round takes about 5 seconds. And I'll speed up this video to show all 100 rounds being generated in this test. So the generator's done running, and we can look through some of the higher scoring options. So the higher score meets the layout met, for example, 88% of the room relationships that we inputted. And the intent is not to use these as finished floor plans, but to quickly show alternative options early in the design process. So these show a variety of room relationships and resulting outdoor spaces that could influence the final design. And my hope is that quickly iterating many ways the same groups of rooms can function and relate to each other allows the designer to focus on how the building could be enhanced further. So this project is still a work in progress, but feel free to reach out if you'd like to discuss this further. Thanks for watching.